Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In a previous Space News series, Thunderbolts contributor Andrew Hall presented his groundbreaking thesis on new aspects of electric universe geology. Of course, electrical scarring of any kind is not part of the traditional geological toolkit. In Hall's arc blast theory, he has attempted to explain the formation of mountains and other features on Earth through the principles of plasma physics and electrical engineering. In this episode, Hall explores the possible role of electrical discharges in earthly volcanism.
El Pinacate y Gran Desierto de Altar is a geologic wonderland for volcanologists. It should also be a laboratory for the study of the electric Earth. Pinacate is a monogenic volcanic field in Sonora, Mexico, that lies just south of the Arizona border, 70 miles east of where the Colorado River empties into the Sea of Cortez. It is a protected biosphere reserve and World Heritage Site. Monogenic volcanic fields, meaning each eruptive feature in the field is the product of a single short eruption of unique magma, are not uncommon in North America. In fact, Pinacate is one of 50 that dot the landscape from central Mexico to Colorado. What makes Pinacate special is its pristine nature, for it is largely untouched by human hands or the effects of severe erosion. Its location in the desiccated Altar Desert of Sonora is the reason it has remained pristine. As Edward Abbey wrote of the Altar, "This region is the bleakest, flattest, hottest, grittiest, grimiest, dreariest, ugliest, most useless, most senseless desert of them all. It is the villain among badlands, most wasted of wastelands, most foreboding of forbidden realms." In other words, it was one of Abbey's favorite places. Geologists insist Pinacate is dormant, but recently so. Its last eruption is dated a mere 10,000 years ago. But local lore of the Tohono O'odham people, descendants of the ancient Pueblo culture known as Hohokam, insist there have been two minor eruptions in the last century, one in 1928 and again in 1934. Seismographic records don't bear this out, say geologists, indicating no seismic event associated with volcanic activity was recorded at the time. Its many lava flows and tephra beds portray the Pinacate as the result of three volcanic periods. First, it developed as a shield volcano, raising the mountain that gives the field its name. Pinacate is derived from the Aztec word for black beetle and is commonly used for the desert stink bug. Identity with the mountain is understandable since stink bugs hold their rear high and emit a foul odor. The next period brought blooms of pyroclastic eruption that left over 500 volcanic vents and cinder cones across 770 square miles. Its final phase created several Mars craters. The Pinacate is best known for Mars and the rings of tuff they create. There are about a dozen Mars and tuff rings in the Pinacate. The crown jewel is El Elegante, 1 mile in diameter with steep sides sloping to a depth of 800 feet. It looks like a giant bottle cap was pressed into the earth to leave the depression. Its size, symmetry, and scalloped edges earn the elegant one its name. Mars are one expression of a diatreme volcano. Their creation is brief and explosive. Magma rises beneath moisture held in an aquifer, subsurface stream, or permafrost, and vaporizes the water in a series of blasts that last from a few hours to several weeks. A shallow crater with a bowl floor and a low raised rim is left over a rock-filled fracture called a diatreme. Typically, Mars fill with water following eruption, leaving a lake. The Mars of Pinacate are dry and accessible. No certainty as to the formation is truly known in consensus science. The inverted cone shape of a Mars diatreme has been generally assumed to form by shallow explosions first, followed by progressively deeper explosions. The explosions are thought to be caused by the instant vaporization of groundwater when it contacts hot magma. If deep explosions occurred first, they would hollow out a wide void, not a conical vent. but the shallow first theory should produce ejecta of shallow rock covered by later deposits of deeper rock. Examinations of Mars show that deep rock fragments are well mixed with shallow rock, implying explosions occurred throughout all depths at once. Geologist Greg Valentine, a professor at the University of Buffalo in New York, and James White, an associate professor at the University of Otago in New Zealand, have created a new model to account for the jumbled order of explosions. Their model, published online by the journal Geology, suggests individual explosions are relatively small and shallow explosions more likely to cause eruptions than deep ones. The model did not include subsurface electrical discharge as a possible causation. Perhaps it should. The likeness of Pinacotti's craters to lunar craters made it a perfect training ground for Apollo astronauts. It's also a reason the area should be of interest to the study of electric Earth phenomena. Close inspection of craters and other features in Pinacoti reveal more than a casual resemblance to the craters of the Moon. Let's take a look. Beginning with El Elegante, the Google Earth image below shows a rim crater at the 4 o'clock position, the only flaw in its beautiful symmetry. It is explained as an older cinder cone that was split in half by the Mare eruption. Rim craters also occur on other Mars in the Pinacoti. In fact, more than half of the Mars have features that appear to be rim craters. Perhaps it is normal for Mars to occur at the edge of older volcanic vents. Perhaps the older vent plays a role in creating the Mar. Or they may be what they look like, a feature caused by a filament of electrical discharge. Rim craters occur with such regularity on rocky bodies in our solar system, it is statistically absurd to think they are caused by chance impacts. They are a known feature of electrical discharge, as filaments of spark will form craters within craters and often stick to the rim of a crater previously formed, leaving rim craters. This Mars shown is 0.9 miles wide and 250 feet deep. It also displays scalloped edges and a large rim crater at the 5 o'clock position. Another small rim crater is at the 9 o'clock position. Most confusing, assuming the consensus science view of how Mars are created, is the small tuff rings in the floor of the crater beneath the large rim. In this case, the rim features can't be the remnant of an older cinder cone, since they could not possibly have pre-existed the Mars eruption. It must be the remnants of events that followed the sequence of eruptions that made the Mars. But where is the debris from this later event? This Mars, 2,400 feet in diameter by 50 feet deep, at 6:30 o'clock has 3 apparent rim craters blanketed by inflow of red ash, as if the event flattened the cinder cone next to it by pulling it in. The next images show a rim crater at 6 o'clock and a primary crater that is 2,600 feet in diameter by 150 feet deep. The triangular wedge you see is actually a slice from a pie-shaped depression at the rim. The next images are of a Mars 3,400 feet in diameter by 600 feet deep. It shows a rim crater at 11 o'clock. Gray ejecta blankets the rim crater, but the side view shows the rim crater has a steep conic depression below the gray material. The gray ejecta is obviously associated with the Mars and blankets the slopes and lava flow of the red cinder cones nearby. This appears to be the case with the other Mars, indicating they occurred in the latest series of eruptive events. However, the question should be asked whether the material was blown out or sucked in by the event that made the crater. The gray blanket is formed into dunes. See at the top center of the photo above the rim. Dunes exhibit a gentle slope to windward and steep reverse slope to leeward, suggesting at least the final winds of this dramatic event were directed inward to the crater. The best example of a rim crater in the Pinacoti is Cerro Colorado. Thought to be the result of multiple blasts through several events, the main crater is 3,200 feet across with a canted rim. The lopsided rim is thought to have been created by prevailing wind depositing ejected material preferentially to the south, or because subsequent explosions caused the north side of the rim to collapse. depending on which consensus theory is chosen. Neither provides a satisfactory explanation of the rim's appearance. On closer look, it could also be interpreted that the material was drawn in, the way a tornado draws ground winds to it to create the lopsided rim. The neat, even edges and compact symmetry of the aureole around the rim appears to be caused by inflowing winds rather than the several explosive outward blasts. In the next image along the crater rim can be seen layers of deposition consistent with the effects of winds being drawn inward to the crater. There is no question that Pinacati is a volcanic field. The lava flows, ash, and tuff attest to that. We see active volcanoes around the world. The Yukon eruption on the Alaska Peninsula in 1977 created 2 maar craters. The largest of these maars, now filled with water to form a leg, erupted for 10 days to create a crater 1,000 foot wide. The photos show the eruption and resulting maar. The largest Pinacati maars are 1 mile in diameter. The largest known maar on Earth is on Alaska's Seward Peninsula and is 5 miles wide. The magnitude of the Pinacati and Seward Peninsula events dwarf the Yukon or any other eruptions seen in historical times. Consensus science does not explore the electrical nature of volcanoes and the potential effects of an intensified electric field. They should be interpreted with electromagnetic effects in mind to understand them fully. In this news article, we've looked at the physical similarities of Pinacati's maars to lunar craters, including the distinctly electrical appearance of rim craters. Lunar craters are believed by consensus science to be formed by impacts. Pinacati's craters are a known volcanic event. Could it be their similarity isn't coincidence, but commonality of cause, that cause being electricity? In part 2 of The Mars of Pinacati, we'll look at more similarities and expressions of electrical scarring. Thank you.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.